Okay, I will just double check this just in case I've knocked something. So bear with me. Hello, hello, hello. Okay. Awesome. Yeah, that's working. So we left on me being a little confused about the angle between two vectors. I've had a little look at them. Well, I've had a rather large look at them. Basically because what confused me is like the usage of them. I suppose the usage is kind of clear, but not in the James Clear kind of sense. And I think there's still more work for me to do on understanding that better. But essentially, I found out that if you have so I did know this stuff. It's just annoying that you forget it. If you have a coordinate system like this, and you have a vector A, well, let's try that differently. And you have a vector B. Well, actually, let me just put this down here. So let's go B. What I found out, some interesting things. So two examples that I thought were interesting. Why do you need to know what the dot product of something is? And it's not the angle between two vectors, right? So this is a different thing. We'll call this theta. So the dot product, I've heard it summarized like this, is how much a vector points in the direction of another vector. It seems a little bit ambiguous. Like it's hard to kind of understand its actual use, but it's trying to say if I just project this down like this is saying that A projected onto B, how much of A is pointing in B's direction is what this tells us. So I had number one, let's just well I can't bother to write it out, but basically how much of one vector is pointing in the direction of another. Very ambiguous. I don't really like that explanation. The other one to summarize this is like, well, what does a projection actually mean? What does that mean in real life? And I heard someone talking about like if there was a sun, um, and the sun was casting a shadow onto this like I don't know, I don't know, a, a, a penis, right? How much of that penis would cast a shadow onto the floor? So that was interesting to think of it as a shadow and that being a projection. But I still didn't quite like that because I still wasn't sure about the whole thing. Let's just try something else now, which I got this from oh, he's rather famous actually. I can't believe I can't remember his name. Um, Walter Lewin. He's like an MIT lecturer, and I quite like this one because he said, imagine I'm on a table. He's like standing on a table, right? And he starts standing here, and then he walks in the direction of B. So he's now at B, right? But at the same time, someone was moving this table downwards. Well, to him, he will still be at B, but to other people looking upon that table, he would have moved down. Let's say this is S amount. Whoops. Oh no, I can't undo. It's crashed. Sorry about that. Let's try this again. Let's say this is S amount that we move the table down. Then he will actually be over here. So you have, if I recall this correctly, you have this vector moved by this amount, or maybe even better. I can't believe it's not working. Let's do this instead. It's a bit more clear, I think. If you move the table over here, then he will be over here. And so it's how much has he moved over there? So you can kind of project onto this, um, onto this S, like it's basically this amount he's moved over, that kind of thing. So it, I need to learn more to be able to explain it better, and I think I need to see some actual active examples. And I know that they do this kind of thing in machine learning because we've done it right on my other episodes of computational biology. We've done this kind of thing in machine learning, but I think when it comes down to actual real world examples, I like those. I understand that they're not always possible, but still, I feel like it's something I'm missing. But needless to say, I think the projection of like the sun on a penis onto the floor, casting a shadow, you can start to feel the reasons behind it. So that's what the dot product is, and so that well, let me just undo that. Oh, of course I can't undo it. Let me just close this down because it's mucking up. Okay, fine, whatever. So anyway, given that, now we want to see the the angle between A and B, right? And so as we saw in the last part, and I was just being like, I just find it very hard to visualize and understand it. What we can do is the angle of theta is worked out like so. There's an equation. I think it might be it's a mixture of Lagrange, who is a guy, and someone else maybe. Maybe he did this other thing as well, but I know he came up with a dot product. But essentially, you take the dot product of A and B, and then you divide it by the magnitude of A times the magnitude of B. Um, well, actually, let me just think about this. So it's cosine theta is equal to this divided by magnitude of A times the magnitude of B. Oh wait, you know what? I've written down here, so let me just not confuse myself. Um, oh, that's right. Yeah, yeah, yeah. Okay, cool. And um, and so in order to get theta, you can basically, well, you think of it like an equation. What's the opposite of cosine of theta? What's the inverse, right? So you get cosine, or sorry, theta is equal to the inverse of this because we want to move that to the other side. So it's actually cosine minus 1, which is the arc cosine of A dot product B, or the dot product of A and B, divided by the magnitude of A and the magnitude of B. So this is like an equation, right? This is an equation, and then this is like manipulating it so that we can get hold of theta. So now we have the problem of, well, how do you get the dot product and how do you get the magnitudes? So let's start with the dot product. The dot product of A and B is the same as, let's imagine A is a vector of 2 and 2. This is like x and y component, right? And B is similar. Let's do 2 and 1. Okay. Um, well, actually, let's just draw that. So this is, let me just delete this and repopulate it. So let's go, this is 1 and this is 2, this is 1 and this is 2. So So A is 2, 2. There it is. And B is 2, 1. 2, 1. Good so far. So A to do the dot product, let me just move this down a bit. You basically just add this one, sorry, multiply this one by this one, and then plus that by multiplying this one to this one. So let's do that. It's 2 times 2 plus 2 times 1, right? That's the dot product. That is the equation that I think Lagrange made. So to represent that projection, to represent how far something has moved in a certain direction with respect to the other vector. So so in this case, 2 times 2 is 4, plus 2, so the dot product is 6, okay? And now we've got these other ones to do. So how do you do the magnitudes? Well, I don't know who did this, but here's that. Let's just box this off. So that's first one. Dot product. So next one, whoa, is the magnitude. And so that is done by doing, let's take these two things again. 2, 2, 2, 1. You basically do 2 times 2, so it's x times y, plus 2 times 1, x times y. But these are squared, I think. Let's have a look. Yeah, they're squared. So you do that, and you basically square them. And then you take the square root of that. And this equals... Oh, I'm so sorry. Sorry. It's actually like this. My apologies. So this is for the A. We want to find the magnitude of A. So the magnitude of A is equal to the square root of x times y squared. And then the magnitude of B is going to be equal to the square root of 2 times 1. I think that's right. No, that's wrong. Nope, wrong. My apologies. It's actually x squared plus y squared. X squared plus y squared. That's how you do it. Okay, so I knew I'd forget this. So this is the magnitude. And so if I take that, let's just work this out. So 2 squared is 4 plus 4 is equal to the square root of 8. And the square root of 8 is square root of 8. Can I do that? No. 8 square root is 2.83. Okay? 2.83. And then 2 squared is 4 plus 1 is 5. So it's the square root of 5. Well, let's do it. 4 plus 1 equals the square root of 5. And that's equal to square root of 5. It's 2.24. Okay. So now we've actually got everything we needed to fulfill our angle equation. So this is the magnitudes. Just a quick one. So the magnitude is like it's like the length of something. So what's the length of A? What's the length of B? For example, if this were Pythagoras, then and we had these lengths here, then we could find the magnitude, which is also be the hypotenuse, right? Anyway, they're not equal. I'm just saying it's like a good way of thinking about it in this sense. So now we just plug these in. So we've got our actual equation over here. Let me just. So this is our actual equation, and this is the kind of modified version to help us get the angle. And so the end result is going to be theta is equal to the cosine, or the inverted cosine of, was it 6 over 2.83 times 2.24? 2.83 times 2.24, right? So if we plug that in, 6 divided by 2.83 times 2.24 is going to equal 0.95. Now that's the angle. That is the angle, but in radians. So this is in radians. And obviously to convert it to degrees, I think you do 0.95 divided by, no, times 180 divided by pi, is that right? Can't remember now. Let me just Google that. How to convert radians to degrees. I think it's that. 180 divided by pi, yeah. Cool, okay, so I got that right. Whew, that's good memory. And that gives us the distance between them, the angle between them. So let's just do that. So 0.95 times 180 divided by, where's my pi? Pi. Is that right? Let's actually just, yeah, well, it has to be right, right? So let's go to that, and it's about 55, right? 55 degrees. Now, if you look at this, if 90 is here, this is 90. 45 is about there. So I must have done a mistake somewhere. No, that's what's wrong. Sorry, I forgot the last part. You need to do the cosine inverse. So we've got 6 divided by, yeah, let's do that again. Sorry, I failed that. Failed you. I failed you. 6 divided by 2.83 times 2.24 is 6.4. So 6 divided by 6.4, but then you have to do the cosine inverse, which I totally forgot to do. Sorry about that. It's good to see that it can't have been right, yeah, so that's a good way of checking, yeah. Which is equals to, can you do that? Inverse. How do you do inverse, I wonder? Oh, maybe that one. No, that's logarithm. Oh, second. Okay, didn't know that. So 6 divided by 6.4. 6 divided by 6.4 equals 0.4. Cosine minus 1, 0.94. So I'm just put that into the cosine negative thingy. There it is. And it equals 20.4, right? So now if we go back to our diagram, that looks about right. It's about 20 degrees, yeah. 20, 40, 60, etc., etc. So I think it's about right. So that's how you do it. So now we can put that into our code, right? So if I go back here, it's dot between A and ray trace. And so that's actually not what we want, is it? Because we want to find um, the angle between A and B, and of course we did it here, A dot B, right? Um, or maybe that is right, sorry. Ray trace and location of A. Location of A and location of B. So we want to do, so sorts the array to closest to character by angle between ray trace and climbing hold location. Okay, so we're getting the distance between the dot product between us and A and the dot product between us and B. So maybe we should do this like that. And of course, this is wrong because I need to find the magnitude, right? As well. So in this case, we've got to have um, uh, the components. Let's see if there's a f vector magnitude or length. Get the length, magnitude of this vector. Here we go. Magnitude of A, and then magnitude of ray trace and magnitude of A, right? And so that will be ray trace and location of A. Let's see if that works. What does this want? Oh, okay. It just wants, so I just do that instead. Cool. So now we've got the dot product between A and the ray trace. We've got the magnitude of the ray trace. We've got the magnitude of A. So now we can find the angle of A and ray trace, which is going to be the arc cosine dot product divided by magnitude of A times, sorry, ray trace times A. So that will give us now the angle. Good. So now we just need to do the same for B. Let's just copy this and just put B. B, 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 B. And then of course we want to convert those to degrees. I guess. Do we even need to? I guess we don't need to, actually. Just can do it. We don't, I mean, just don't need to. So we just need to now go angle of A, angle of B. And that's it. Whew, okay, cool. That's a good bit of math there. So now if I go and compile that, what have we got? Magnitude of ray trace, redefinition. Oh. Okay, yep. Don't need that. It's already been worked out, right? So now if I connect, yes, that's awesome. Yeah, pretty cool, huh? All right. If we don't have two choices, that's interesting because actually at that point if it's too far away, if it's more than 45 degrees away, we should not choose it. But that's definitely working. That's kind of sweet. Uh, Lovely. It's funny how S put a smile on my face. I could almost cry. Okay, fun days, fun days. Gotta love maths, man. Gotta love maths. I hope this helps in some way. I will go back and try and get these better like examples of practical examples of what they're used for. Like I understand that we've just put them to use to figure out something, but at the same time, what is a dot product? It's still like projection. It's like I want to visualize it more. I want to have it more tangible. So um, anyway, that's that. So now we've got that working. We've already got the length of those vectors. So when I like take action on it, like to move to it, then I want to pass that into my blend space. Um, yeah, I want to pass it into my blend space. So probably not the best time to do this now. But how long have we been on the stream? Not that long, hopefully. Yeah, 30 minutes. That's fine. So um, well, it's kind of tempting. It is kind of tempting. Let's do it. Let's do it. Do it. So if I go to my plugin where my left blend space is, let's see, did I do it? Yeah. I don't think the right is really done yet, is it? No. We need to feed in the value and get the animation out. And the way to do that, if I remember correctly, is to have an animation blueprint. So what we'll do is create an animation blueprint. Oh, just animation. Animation blueprint, there it is. And it's going to be for this one here. Cool. And if you go into here, oh gosh, I've forgotten all this stuff. I think you have to have like input. Where's that come from? It's called a state machine. So you add a new state machine and you plug that into there. And you go into here and you say, well, let's see. Well, I don't think it is a state machine actually. Maybe it's an anon graph. Add graph. Oh, how does this work again? No, this is right. This is right. Yeah, yeah. So this state machine is going to be climbing or uh, climbing left, something like that. And we start with a state, and we say is climbing, or maybe it's like not climbing, and then you define a transition. So then you go is climbing left, uh, and then you pull it back to not climbing. And basically these act as transitions. So like when am I climbing left? Because when is denoted by a condition. Like, well, if they're going left, then we start to feed in the values. And then the animation here is going to be that blend space. So blend space. Well, let's see. Here it is. And you see, this takes two parameters, which we'll take from our character, and that will give us the correct values, the correct part of the animation from that blend. I've explained that really badly, but bear with me. So now we need to know the distance between the character and the climbing hold in two components, x and y. So let's do that. So we're reaching out to climb hold. We've got that as a vertical axis value, but we do not have the distance to the next actor. So I guess we want we want to get the distance from this. So target distal climbing hold actor. If we were to go back to the to implementation, I think what we need to actually do is denote the current and the target, right? So let's make a new one here. Or maybe it should be that one we use again, closest distal. It's that one, I think. I think I should probably reword these though, shouldn't I? Because this really is the current, and that's going to be the target. Yeah, let's find where this is used. In fact, let me just save this before I make a mistake. So this is going to be target. This is going to be current. Right? And now we've called them that, we can change this over to the correct thing. So target equals that. Oops. So target equals that, and then the current equals current like that. Cool. So I think that makes a bit more sense now, doesn't it? Because if we let's go to our stuff here, we're going to go toggle attachment. So if the current distal climbing hold actor is present, that means we're already attached to something, right? And so you detach. And detach sets the current to nothing, whereas attach sets the current to the target, yeah? And then the target is no longer applicable. So that makes more sense, I think. And then reaching out is attached, returns, yeah, that's cool. And reaching out, well, actually, what's this closest one as well? So move to is going to go, if there is a current one, move to, if you do have a current one, then do that. Otherwise, do nothing. Because you have to attach first, I guess. Yeah, I guess you can't. Well, this is a bit wrong, isn't it? But let's see. because move to climbing is going to be called from the character. No, controller? Oh, I didn't think I'd even implemented that yet. Oh, I have. It's ticking. It's ticking on the system. So we're always trying to move, but okay, we're always trying to move to it, but only if there is current one. Otherwise, don't bother. Oh, that's interesting. Um, that is interesting. I guess really it should be when the target's set, right? So if target, then start moving. Move to climb and hold curve. On time, current. Then it's going to be if current, do that. Else, get owner location. Because well, it's always going to be owner location, isn't it? Because we don't care about the current. It's going to be that. Current hold actor character location. Oh, that is the target. Oh, I see. So that's where we're going to move to, I see. And then if the character is cast, then the width of the character. Wait, let's read this properly. Undo that. Sometimes I forget what I've done. So current climbing hold actor. Get the animation curve, okay. And then current climbing hold actor character location. That's just actor character location. And then this will be target because we're moving to something. Yeah, it's the target, which is going to be the target. And then if we have a character, we want to do the current one. Well, we just want to do the current character, right? So it's just or it's the target. Get the forward vector of the target, and then this will be um, that, I think. And this is the alpha value, and then we're lerping between the character and the target location. And then we set the owner. So this should still work. And when we connect, so you attach, if it's true, no, we want to toggle attachment. Will attach. So if the current is empty, then we want to attach. And if there's a target, so target needs to be determined by the scanning, right? And so when scan made, scan is called on the tick. And so here we set the target equal to that. So the target will be set, and so we can attach if the target was set, and if we have a curve, and then the current won't be set at this point. But we can attach the character to it, to the target, right? And then we empty the target. No, that's not good. We don't want to empty it yet. And then we move, so we attach to it. So we set the target, and we attach to the target, sorry. And then we move to it. And then if we detach from it, then the current is that and the target is that. So let's just run through that one more time. Number one, we're ticking. It says scan for nearby climbing holds. Okay, so go and get all the things, sort them accordingly, and when we found the closest one, we set that to our target, right? Now, we're going to move to it. Yeah, this is a problem. So should attach should be set by so there needs to be another value. Is attaching. No. Should has user wants to attach. Denotes whether the user has asked to attach to a climbing hold or not. So it's now attached to climbing hold, or toggle attachment, attached to climbing hold. Will not only set the target, it'll set this to true. And then only if this is true, So attach to climbing hold. If the user wants to attach, what are they attaching to? Needs to be set by the scan for nearby thing. But they can only apply for attachment if they are near enough to one. Muddled things around a little bit here, haven't I? Trying to think how to clarify this mess. Because I'm going to be walking nearby. Here you go. And all this time, I'm not close enough. So I'm not within this radius, so I don't care about it. So there is no close by. Close by, that's the one. That's what we want. Close by climbing hold actor. That's what we want. And I think that might also eradicate the requirement for this, but let's just see. So we're scanning, and if we're close by, there you go. Cool, okay. And so now we're scanning and the user hits the button, so they're toggling. So attach to now says, here's my target. So the target is going to equal the close by. Oops. Yeah, so attach to climbing hold is just called when the user toggles it. So if there is a target, no, that's it. It's just simply there's no check required. It's just that. No, or actually it's if closest is set. And then if there is, then we set the target to that. And then I guess we set this to null. And then as we're moving to it, so now that's done, we've got this ticking, it's scanning still, but move to climbing hold actor is now going to do it because there's a target. And then once we've reached this, the target can be nullified. The current is the current a thing? The current is going to equal that, and then that can be nullified. And then close by can reprocess itself. And then when we move into it, it's all about the target. So go and get the location of the target. That's correct. And then reaching out to one is a little different. Reaching out is I'm already attached to one, so if current, then we can do all this stuff. because only if we're currently holding on to something do we want to be able to reach out, right? And this is allowing us to select. And then this is where I want to set those components, the X and Y components that I was talking about, or Y and Z. And that's based off of the distance to this. So let's do, well, let's do vector. Um, this. There it is. And then I think finally I need to, well, that's the distance, so I need this in X and Y, so, or Y and Z. So it's going to be that dot, well, that's going to be 0 actually, 0, and then fuck, it's going to be Z, no, what, Y, and then Z. Minus, can I do 2D? I wonder. Oh, there is a distance 2D, I wonder what that returns. Is that also a float? Yeah, that's not what I want. I think this is working, but I'm feeling a little scruffy here, so this might not be quite right. I mean, this will definitely work. It's just if it's not able to be a little bit neater somewhere along the lines. Anyway, let's give that a try, because we've changed quite a lot now, so oh, and this should also be updated when moving, right? So reach out to climbing hold, that sets the distance, but then this also needs to be calculated whilst moving. Um, like this. think that's right. Let's try that anyway. And maybe we should have also printed out something. So let me just go and see if I can find a print example. I think we did it on the here somewhere. Or draw text, is it? This isn't print text, was it? Draw text. Where did I put that stuff? Was it in here? Debug line. Debug text? Oh, on-screen debug message, okay. Oh, I see, okay. So we were doing it in here somewhere. I think we must have removed it. Maybe it was in here, that's right, yeah. But debug text sounds good. So let's go to where we're ticking, and we'll just grab the distance. Oh, I can't remember how to do this. I think it's like format string C++ draw debug add on-screen debug message. Add on-screen debug message. Let's see what they say. That's the one I want. %f. So it's that. Then it's that, and then I think the commands for this are the things you want to pump in. So let's do y and then z %f. So it'll be distance dot y distance dot z. Okay. Good. So we're not connected to anything yet. Ah, that's interesting. So maybe I've mucked this up now. I'm also gonna plot these things out because they're probably quite useful, I'd say. And is this key right? I guess they'll all just kind of pile on top of each other, which is fine. Let's do that. And we'll say this is radius effect. Just because it keeps resetting itself, so I want to make sure I'm on top of that. Yeah, so that's looking pretty reset, isn't it? Actually. Let's see what's gone wrong here then. Yep. All reset again. Yeah, I need to figure that out basically, because that shouldn't keep resetting like that. But that's working, isn't it? So it's 100 above me basically. Since I can't detach anymore. Let me just make sure I can detach, because otherwise we're stepping backwards. Detach from climbing hold. Yep. Let's see. Nothing. So that means that the check for toggling is wrong. So let's see what I've done here. If the current one is something, then detach. So I guess this gets cleared out somewhere. Equals null. That's fine, but interesting. Oh, okay. I was That's so weird. What am I doing wrong here, huh? What am I doing wrong here? Toggle, toggle, toggle. Let's toggle this one up. It's getting pretty funky, that. Um, yeah. So current's null, so it's going to attach. Agreed. And then current's not null, so it should attach. Cool. Current's null, so it should attach. Current's not null, so it should attach. Current's null. Interesting that it's not aligned correctly. Current's not null, so it should attach. Works now. We've got a race condition here, I think. It's possible. An odd race condition. Hmm. Takes a little while to let me unlock again. If I keep pressing E, it doesn't always come through. Uh, let's solve that after anyway. So now okay. So I actually think maybe it's taken a little bit of time to kind of action itself in, which is a bit interesting, huh? Yeah, taking a little while to execute. Not sure why that is. Interesting. Anyway, so once we're attached, now what? Like, how do we action that it should start walking? Maybe it shouldn't wait for an action, right? So after we're attached, then you can just move, right? So after we're attached, we should just move. That means that move to climbing hold needs a target. Once we've reached it, the target's no longer set, and we're waiting to toggle. We're waiting to reach out the climbing hold actor. which comes from the controller, right? This one here. But actually, this is waiting for if we're on a current, so that should all still be fine. Yeah, we've got a current. So I guess that should, yeah, okay. And so here it needs to reach out, the climate, which needs to start moving, and moving's not going to happen because we need a target. So in this case it would be target equals that kind of thing. I don't know if that's going to get me into a permanent loop now, but let's see how it goes. No, I think I'll call it a day after this. And if that's true, then move is going to start happening. There it is. Ah. So maybe that's just too quick for it to register. No, it's not. Okay, here we go. And what's stopping that from moving then? If... Oh, of course. I need to reset this to 0. And compile it. I think that's it. It's going to be very snappy and wrong, but yeah. Because we need to wait. Oof, it's a bit grubby, isn't it? Because we need to wait for it to finish its action, but it's just interesting though, because I think it is. You'd think it was. I guess I just have to slow it down a bit. It's just a bit fast at the moment, maybe. So if I went to the content curves, can I stretch this? Rather than 1 second, it would be 2 seconds. Well, it's definitely not waiting, is it? So our curve, wherever that's used, get time range, n minus start time. Time range of curve, end minus start time. That'll give us the time, I see. So once we've got the time range of curve, we are doing, in the movement, we're doing that interpolation. Where's our interpolation? There it is. Get float value from progress. Ah, that's adding delta time. It's not adding. No, that's right. Progress along time range of curve is that. That is correct. So, and then we get the value from that. And the value is a single value coming out. It's over 2 seconds. And so it's not that, it's target. So it's not the amount of time range of curve. No, it is. Why is it going so fast then? It's a bit weird. Not quite sure I understand that yet. So I actually think that's working at the start, because that's why I can't 2. Yeah. So if I increase my curve again to like 4, I'm not gonna be able to do anything for 4 seconds, right? 1, 2, 3, 4. Then it moves. So that works. So that's good. And I think actually then that means that 1 second was enough. It's just not waiting between movement. So it comes back in and we set pros long term curve to. So I wonder if some of them don't have a time curve. Like, let's just see what's happening here. Oh, maybe I put that in the this component. Yeah, so that's using that. That should be fine. And it's getting that from the actual curve itself. Get float value. Wonder what this says here in time. And once we've hit it, we set this back to 0. And and the next one is set straight away, but then this should be disabled until we get to the next one. And the value is okay. This might need to wait until tomorrow or another day. So that's working. It's when, so it's like, it shouldn't go that fast. Yeah, something's getting interrupted there. That's correct. We're doing a lerp between the current location of the actor, the target, and the current float. Not sure about this. Hmm. This is interesting. Because it's got to take 1 second to get to the end. Why is that shooting over? Why is it allowed to shoot back over? Maybe it's because of this reassignment. But that is correct. So where is this getting used? Detached. No, is attached. Um, reach out to climbing hold. That's a target. And only once all that's done is it's able to go back into play. And it does another second, and then it's set back, and it's like, okay, well I'm gonna reach for my. Oh, I see. So reach obviously. Um, yeah, reach is only triggered by the. And this only works when this has a target. Target only gets set when. Right, so we're pressing a direction, and so it's running this, right? And if there is a current one, which there is because we just connected to one, then it's like, okay, let's go find the next one. And then it goes, okay, this is the next one. And then of course this is all ticking. And so it's like move to that. Interestingly, this is not required actually. So if I'm already attached, then scan. Otherwise don't. Maybe the scan was buggering things up because scan is going to set close by. That's not causing a problem though, so that should still be fine. I mean, it was irrelevant anyway, I don't need it, but um, good to turn it off. That's interesting, isn't it? 'Cause it's now never got there. I wonder if that's the problem. So I suppose in that case it should be not only is setting that, it should actually set the actor to that location. Because there is, it's gonna like maybe it might creep over, might not creep over, and in that case you might never get to the actual end of it, I guess. Well, this is interesting because oh, that's right. I need to do this right. That's right. Not so interesting. Sorry for no talking. I'm just trying to focus on this now. So the target is equal to the target, and then we go and set the location with that plus the forward vector, and then we set the location. That looks about right now. Oof, getting a bit tired. What did we do wrong? This. Oh, has it done? Has it done the empty out again? Yeah, it's emptied out again. So I need to figure that out. Oh, it hasn't. It has not. And yet the radius of oh, okay. Radius area of effect is not showing anything, so maybe I did that wrong. Radius area of effect. Oh yeah, I didn't put that in there. But that is no longer working, so I've mucked something up. And I mucked it up by, what did I do last? I said uh, if there's a target and if there's a character. Oh, that's why. Yeah. So there was supposed to be one more. Um, or one less here, I guess. That's better. I think that's right now. Yep, that's probably right. Okay, cool. Still doing that funky. Not sure I understand that. Um, oh, we're setting it to that anyway. Duh. Okay, let's try that again. There we go. Got it now. It'll certainly prevent those little kind of half movements. It'll always go to it now. And in fact, it does seem still buggy. Um, this lerp. If I maybe muck something up here, what's my curve look like? 0. Um, this should be at 1, I think. Because it's going to take 1 second, it's going to go fully onto that thing and then back down. Oh, I don't know. Okay, yeah, I just need to stop now. Because it shouldn't jitter. The lerp should exactly tie it in correctly. So this is wrong, and we're disguising an actual problem here. So let's just comment that out and let's just store this for next time. I think we've made good progress though. So thanks for watching, and if you're watching in the future, thanks, and keep learning and keep loving. Bye for now.